Alright, so I was super fucking confused on these two questions in class. I stayed after the professor, and he explained them, and walked me through them, and I get them. I get them now. Alright, so I'm going to explain. So for both of these questions, the professor asked us, why? Why are they discontinuous? He's telling us, we know that these two are discontinuous. Our job is to explain why they're discontinuous. And in order to do that, we'll start with B. We're going to have to look at the definition of a continuous function first. So, of course, we have the limit of f of x as x approaches a equals f of a. Cool. Now, we can use that to understand this function better. We can say, all right, if this is continuous, then this should be true. The limit as x approaches, in this case, 0, should equal f of 0. Normally we would ask, is this true? Well, we already know that it's not going to be true. We already know that this is discontinuous. So we know that the answer to this is going to be no. The limit as x approaches 0 does not equal f of 0. But we need to prove it. So the way we're going to prove it is we're going to look at all of that shit that we just learned about limits, and we're going to go down the list one by one until we find something that we can apply. So if we can't use a fundamental limit, we'll say, okay, can we use a limit law? If we can't use a limit law, we'll say, can we use this theorem? You know, so on and so forth until we find something that works. And for B in particular, we go down the list and we find that the only thing that makes any sort of sense is that this must be a one-sided limit. So what we do with that is we find, okay, well, we know that these are one-sided limits. We know that this is going to break up the graph in that particular type of way. But what are those limits? We have to prove it. So what we do is we first take this top part. We ignore this for now. And we go, okay, well, the limit as x approaches 0 from the positive side for this one of f of x equals what? How do we find that? Well, what we would just do is we would take values that are close to 0 but not quite 0, and we plug it into this function. So, for example, if we took 1 over 0.5 squared, that would equal 1 over 0.25 equals something bigger. I'm too lazy to actually do that. But basically, we would get, okay, something bigger. We could do that with 0.01 squared, and so on and so forth. And we would find, for this particular problem, that it would trend upwards. We would get bigger and bigger and bigger values, because if you divide by a smaller number, you're getting a bigger, you're going to come out with a bigger value. So, all right, we see that as x approaches 0 from the right, it's just going to get bigger and bigger and bigger infinitely. All right, shit, awesome. Now let's try from the left side. Well, guess what? This is squared, so negatives aren't going to matter. So once again, the limit is, it's just going to keep going up and up and up and up and up. Because if you put that negative number in the denominator, if you have negative 0.5 squared, well, it doesn't matter because you're squaring it. It cancels out. You just get the same fucking thing. Awesome. So that's also infinity. So since these two match, we know that the limit as x approaches 0 of f of x being just this top one here, is going to be infinity. Cool, well, that's not a one-sided limit, but we don't know for a fact that these two aren't one-sided limits of each other. So, essentially, just because this matches, that doesn't mean that the whole thing matches itself. That's a really stupid way of saying it. You'll see what I mean, I promise. So now, we're going to do this one. The limit as x approaches 0 of f of x equals, well, it equals 1. Simple as that. It's 1. Cool. Well, we can see that these two are different. That's not, that, no. Infinity does not equal 1. There is a disparity. They do not equal each other. This is incorrect. Therefore, this is a no-no. This is discontinuous. Yeah. So, awesome. Let's do C now. Let's go ahead, go back to our definition of a limit. We'll have the limit as x approaches, in this case, 2. That's what we're looking for, of f of x. That should equal f of 2. Is this true? Well, again, we know this is discontinuous. We know that's going to be no, but we just have to supply evidence. Let's go to our hierarchy. What the fuck can we do with this? Well, we can't apply fundamental limits. It's too simple. We can't apply limit laws. We can't do this. Oh, factoring. We can do factoring for this one. This can be factored. So fuck yeah, let's do that. Let's factor that shit. X squared minus x minus 2 over x minus 2. That's gonna be x minus 2, x plus 1 over x minus 2. Shit cancels out, equals x plus 1. And remember, what we've done with this now is we've essentially said this is an equivalent function. So f of x equals all this shit equals that. So what we're going to ask is, what is the limit as x approaches 2 of f of x? And we're going to look at this version of f of x instead of this version of f of x. Because the thing is, we already know that if we try to plug in 2 for this one, it's not going to work. Which is why we've translated it into something that will work. So all we have to do is we plug in 2 to this version of the function, and we get 3. We find that this limit is 3. Awesome. Fucking cool. We love that. Now, we take a look at this one. The limit, as x approaches 2, of f of x, when we look at this one, well, they gave it to us. It's 1. It's 1. And shit, 3 does not equal 1. So we've just proven that no, this is not true. This doesn't work. The limit and the value are different, but this one we proved with factoring, while this one we proved with one-sided limits. So yeah. Another thing that tripped me up is that C looked really similar to A, in that it said, I believe it was A, it was f of x equals x squared minus x minus 2 over x minus 2. So why is this one different than this one? Well, the reason for that is that we've specified an extra definition of this function here. We've said this function exists here, except for when x equals 2, and it exists here when x does equal 2. This one was simpler. This one is just, shit, tell me where this is discontinuous. Well, x can't equal 2, because it makes the denominator 0, and you can't do that. That's no good, and there is no other place in this entire function that exists where x equals 2. Like it cannot work here. It's as simple as that for this one. X cannot equal 2, but this one, it can equal 2 sometimes, which is why we had to do all of this shit to see, okay, why is it discontinuous? 3 doesn't equal 1. So yeah, I really hope this helped. I know I'm sorry, I'm a little bit scatterbrained. If you have questions, I can definitely answer them. I hope this helped, though. Yeah, cool.